Hey devs, welcome back. Today we are looking at problem 104, which is part of the LeetCode 75 series. The question is titled Maximum Depth of Binary Tree. Given the root of a binary tree, return its maximum depth. A binary tree's depth is the number of nodes along the longest path from the root node down to the furthest leaf node. And then we're given an example where we have 3, 9, 20, 15, and 7. And the 3, which is the root, that one is level 1. 9 and 20 is level 2, and then 15 and 7 is level 3. So the output is 3. Constraints are the number of nodes in the tree is in the range of 0 to 10 to the power of 4. So because there is a 0 over there, that gives us a hint of what our base case can be. And then our nodes value, which really doesn't matter, but it's between minus 100 and positive 100. Let's look at the whiteboard and just try and get a better understanding. A binary tree by nature is any node that has got two branches. A node can be depicted by just a circle with some sort of value inside. So I will just look at the example. So the value is 3. So that is our root node. And then most of the time we will have a left value and a right value. So let's just call this L and then R. And this could have another node, 9 in this case. So could right, which is 20. And then 9 also has left and right, but they're both set to null. So in this case, 9 is actually a leaf node. So what we're supposed to figure out is, like, if we start going down the tree, so let's just complete this diagram by adding these two nodes as well. The idea is that if we start going left and then right, the idea is we keep on going down in one direction and we keep on incrementing our count. So we start with root and our count will be 1, and then we go down and then we get a count of 2. So we increment count, we get a count of 2, and then after that we hit null pointers, at which point we go back to our root. Once we go back to our root, we start exploring the other side that we haven't explored. So we'll go down right. We had a counter of 1 when we are going right. So let's just label this. So this is left, this is right. So we go down the right side, and then after that we go down the left side, we increment it. So now this becomes 2, then finally it becomes 3, and then at this point there is nothing there. So we go back 1, and then at this point in time counter is 2. So we'll put count as equal to 2, and then we go down this side, then count will be 3, and then we get the maximum of all the counts, which is 3 in this case. And then we just return 3. By the way, sorry guys, I have really bad handwriting, so just bear with me. In binary trees, we have two ways of traversing. So the first one is called depth first. Depth first. So depth first was where we are going deep and then we're returning back. So once we hit null, we return back, and then we go the other side, and then we hit null, we return back, and then finally return back, and so on and so forth. That is called depth first traversal. And then the other one we have is breadth first. So breadth first, we are trying to go both left and right at the same time. Let's change pens. So when you drop a drop in a bucket of water, there are ripples that get formed, which look something like this, and that's kind of how breadth first search goes. Sorry, breadth first traversal goes. So we start from the root and then we go left and right at the same time. So that goes in that direction, and then from here we try going left, there's nothing to the left. Then from the right we go left and then right again, so we go again in that direction. In this particular question, I think either one of the traversals will work. Let's start by looking at depth first traversal. Let's head to LeetCode. Depth first traversal usually is best done recursively. This is because there is less code in it. There is nothing stopping us from doing it iteratively, but I'll just go through the recursive code solution first. So let's think about this. I'm going to create a helper function, which is just called DFT, which is depth first traversal, and this will take in a node and it will return. Think about what it needs to return. And so it needs to return how far down it's gone, right? So in this case, let's see, we want a node and then we kind of want the depth. Let's just start it with being equal to 0. What we want to do now is go down the left node and the right node and return the maximum. That is fairly simple enough, so we can just do return math.max of node dot left, sorry, math.max of dft node dot left, and we want to give it some sort of depth, so we will just say depth plus 1. This will just make sure that every time we are recursing through this, we add 1 to our solution. And then we want to do a depth first traversal of node dot right, and then pass it depth plus 1. So whatever the maximum is, it will try and return it. Now, since this is going to be a recursive solution, like, we need some sort of a base case. In this case, our base case is just going to be if our node is null. If we can simply just do if not node, then we want to return the depth. I hope that makes a bit of sense. And then what we want to do is we want to just return depth first traversal of the root. Let's see if that works. It works. Awesome. Let's try and submit it. Awesome. Now let's look at the theory a little bit more. Why does this code work the way it does? Let's go back to our whiteboard. Let me write down the code really quickly. So we have our helper function, which is const dft, which equals to node, and then depth, which we are going to make it equal to 0, and we are creating an arrow function which checks if let me write it a little bit properly, if not node, then we want to return the current depth, whatever the depth we have reached at. Otherwise, we want to return the maximum of the left traversal, so depth first traversal of node dot left, where depth is +1, and the depth first traversal of node dot write with depth plus 1. So that's our code so far, and really that's the only code that's actually doing anything. The last line of code, which is just return dft of the root node. So let's kind of go through this step by step. I'm going to put in the tree on the over here as well. Let's just go with the tree of 3, 9, 20, 15, and 7. Right. So what we're doing is, first of all, I'm just going to put these line numbers here just so it's easier to refer to them. So what we're doing in line number 2 is we're just checking if the node that we have been supplied to is it's null, right? So in case if it's null, then we're just going to return depth. At this point in time, the first iteration, depth is equal to 0. So we'll just return back 0. No big deal over there. The magic kind of happens in these two lines of code, which is number 4 and 5. So every time we're doing a depth first traversal, we're adding 1 to the depth, right? So if I look at my node over here, my node's value is going to be 3, right? So 3 comes here, and then we have depth, which is 0. Okay, so 3 comes here, and then we're going to do a depth first traversal of the left node, which is 9, right? And our depth is 1 at this point. And then we're doing a depth first traversal of 20, which is on the right hand side, and our depth is 1 as well, right? So now our node kind of splits up into 2. So we have 2 parallel cases going on over here. So let's look at the 9 one first, because it's relatively straightforward. There's not much to do over there. So we go, our node gets replaced by 9, and our depth gets replaced by 1. Is node blank? It's not. So we go on forward. So in this case, since 9 does not have a left child, so we will be sending null over here, and we'll be sending in the depth of 2, right? And then same thing over here, our right will be null, and our depth will be 2. Now when we come back over here, so we're looking at the left again. Let's try and keep track of this, shall we? So the first iteration is 3, next iteration is 9, right? So 9 and 20, right? Now 9 will come with null and null. So 9 has got these two guys. 20 will come up with 15 and 7, right? So now let's see this. So once this is null, it's going to return back depth, right? So it will pop 1 up. So the depth over here will be 2, right? So this evaluated will be 2 this point in time, and then even on the right hand side it will be 2. Oops, I'm erasing too much. Yeah. There we go. Okay, and even from the right hand side it will still send back 2. The max of 2 and 2 is just 2. So at this point in time, when we finish traversing all of 9, we get our depth of 2. So these two are done. This is done, this is done, this is done, right? Now we go to the use case, the case where it's 20. So in this case, now our node is of 20 and our depth is 1. We look at the max of the left node is 15, and we send back, we put our depth to 2, and our right node is 7 with a depth of 2. So we come over here and we add to our call log. So we are sending 15 with 2 nulls, right? So we send 15 over here and our depth is 2. We'll send now a null, and then our depth will be 3, and then finally we will send another null and the depth will be 3, right? So now in this case then 3 will be returned. So from this if statement 3 will be returned. So this will return 3 over here, right? And so it'll return 3 and 3. The max of 3 and 3 is going to be 3, right? So now this is our call stack. Null and null is done, 15 is done. Now we're looking at the final one, which is 7. So we are sending 7. At this point our depth was 2. So 7 now will create new calls with null, with null and another null, right? So in this case then we are calling dft with null and the depth of 3, and again null here with a depth of 3. So obviously this comes back and 3 is returned. So this returns 3, this returns 3. So for 7 we have 3 and 3, the max of which is 3. Now this needs to send it back to the original caller, which is 20. So over here we will have 3 and 3, the max of which is 3, right? And this will send it back to the root node, and so will 9. So now we have 2 and 3, the max of which is 3, and that's how 3 gets returned. I hope that makes sense. Sorry for the jump cut, guys. There was just a few things happening over here. Anyway, now when I look at this code, I think there's a little bit of optimization that we could probably do. I don't think we necessarily need a helper function. So we could get away by just iteratively calling max depth. So what I'm thinking is probably something like math.max of max depth, and then we're sending it root.left, right? And then we're also sending it max depth of root.right. And probably we're going to add b. No, I don't think we need to add a +1. Let's just look at this through, okay? And then what we want to do, because we're recursively calling it, our base case is probably going to be if there is no root, then we want to return back 0. So let's see. If we return back 0, so think we probably need to add a +1. Let's just run it. Let's see how it goes. It does not go well. Let's see. Okay, so that's a slightly more efficient solution. So we don't really need the helper function. Instead, we could just do the whole thing recursively within the same function. I hope that makes sense. And thank you so much for watching this video. And again, I really appreciate you guys showing love to this series. In case of any questions, concerns, please pop them down into the comments. I would really appreciate a like and a subscribe from you guys. And we'll catch you on the next one. Cheers.